Hi there, my name is Dimitris Charalampidis, and in this video, which is actually the second video in my series regarding probabilities, we'll be talking about universal sets, and more precisely, more specifically, we will work together some examples on finding the universal sets. To begin with, let us all remember that by universal set in a probability experiment, we mean the set that contains all possible outcomes of this experiment. Let's begin. Let us assume that our probability experiment is the throwing of one die. Now we care about its universal set. I assume that we have all seen a die in our lives, and we should all know that when we throw one die, there are basically 6 different faces that we can get as a result. These are the face of 1, 2, 3, 4, 5, and 6. So the universal set in this case will be this set, the set that contains numbers 1, 2, 3, 4, 5, 6, where each number is related to each one of the 6 different faces of the die. Let's take it one step further now, and let us assume that we will be throwing 2 dice. When we throw 2 dice, there is always, and we have all seen it happening, either we play backgammon or Monopoly or anything, we might get 5 and 3. So we see here that a possible outcome is not just one number, but it is a pair of numbers. So for the universal set, we care about all possible such pairs. These would be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, and 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, and 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. So in this case, we would have a total of 36 different possible outcomes. A common question students tend to do in this case is whether 1 of 1, 2 is different than the pair of 2, 1. The question is yes, it is. And to understand it even better, just imagine the 2 dice being colored. We have one red die and one blue die. Getting in the red the face of 1 and in the blue the face of 2, and at the other time, in the other case, getting the opposite, so at the red the face of 2 and at the blue the face of 1, you clearly understand that we talk about 2 different cases. So yes, 1, 2, and 2, 1 are 2 different options, and overall we expect to have 36 different pairs of outcomes. Let's leave now the dice and let's move in coins. We toss one coin, so we would expect that we have 2 different options for our outcomes. It will either be heads or it would be tails. Let us now toss 2 coins. I can help myself by creating a tree diagram where here I will put the first toss, which can be either heads or tails, and in the second toss, regardless of what happened in the first one, I will still have 2 different options, heads and tails, heads and tails. So overall, the universal set will contain these 2 pairs. It will be heads and heads, meaning that in both tosses we got heads. It could be heads or tails. It could be tails or heads, or finally tails and tails. So when we toss 2 coins together, we have 4 different options. the cardinality of the universal set in this case would have been 4. And remember that we denote that by n of u equals 4. Let's toss 3 coins now. We will still follow the same process. In the first toss, we could have either heads or tails. In the second toss, regardless of what happened in the first one, we still have 2 different options, either heads, tails, or heads and tails. In the third toss, we could have heads, tails, or heads and tails, heads, tails, heads, and tails. Finally, the universal set will include all these possible triplets this time. So it could be heads, 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 meaning that in all 3 tosses we ended up with heads. It could be heads, heads, and tails, heads, tails, and heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, and finally tails, tails, tails. So in this case, we would have a total of 8 different possible outcomes. Selecting balls from a jar. Let's assume that we have a jar that contains 2 red balls, 4 green, and 5, let's say, orange. One common mistake when we care for the universal set is just write red, green, and orange. I assume that this would be the universal set if we simply cared about the color of the ball. Indeed, there can be just 3 different colors. It can either be a red ball, a green one, or an orange one. But when we care for the balls, the actual balls, then it should be something more. As a result, we would have each one of these balls. So since we have 2 reds, we can denote it by R1 and R2. Since we have 4 greens, we can write it down as G1, G2, G3, and G4. And similarly, O1 for the first orange, O2, O3, O4, and O5. So we expect to have a total of 11 different outcomes. And finally, let us see the selection of students from a class. Assuming that in a class we have the following students. We could have, let's say, Evelina, we could have Jason, we could have Yorgo, we could have Gerasimo, we could have Dorita, we could have Taz, we could have, let's say, Dimitris and Eri. If we randomly select one student, then the universal set would be any of these students, of these persons in the class. So the universal set would include simply all the students in the class. So it could be Evelina, it could be Jason, George, Gerasmos, Dorita, Tas, Dimitris, and Eri. In this case, the cardinality of this universal set would have been 3, 6, 8. We would have a total of 8 selections. And that would be all. Remember once again that by universal set, we define the set that includes all possible outcomes of a probability experiment. There are, of course, harder cases, but in the majority, at least regarding the easy questions, we would expect these examples. Throwing a die or 2 dice, tossing 1, 2, or more coins, selecting marbles from a jar, selecting students from a class, and so on. watch this video carefully, and if, however, you still face any difficulties or still have any questions, please feel free and welcome to leave your comment below the video. As always, thank you for your time.